Hi everybody, welcome to section 4.2 where we're solving applications with systems of equations. We're going to go through a few different types, geometry, direct translation, and motion. So let's review, remember a system of equations. You have more than one equation and you have a set of variables that you need to solve for each one. How do we do that? First of all, you need to read the problem, understand it carefully, read it very carefully, be able to identify what the question is asking you. So are they asking for time? Are they asking for distance? Are they asking for money? What are they asking? Then once you figure out what the question is asking you, that's usually the variable there. Okay, so you choose a variable to represent that quantity, and then you choose variables to represent any other quantity related to what they're asking or expression. Then we translate that to a system of equations, and then we solve using algebra. We can eliminate or substitute or graph, but elimination is usually the best one. And then we can check it and answer it with a complete sentence if it's appropriate to do so. So let's try this one here. We have the sum of two numbers is 0. One number is 9 less than the other. Find the numbers. So let's go ahead and say the first number, let's let x be the first number. And then the second number, we can use y to represent that. The sum of these two numbers, so x plus y is equal to 0. So that's the first sentence. One of the numbers, let's just say y. So one number, that's y, is, the word is directly translated means equals 9 less, that means that you're going to subtract 9 from it, than the other number, and the other number is x. So this sentence, in symbols, we would write y is equal to x minus 9. So now we have a system of equations, yeah? So I'm going to take this here, since it's equivalent to y, and I'm going to substitute it into the other equation. So that gives me x plus x minus 9 is equal to 0. So 2x minus 9 is equal to 0. We add 9 to both here. And then we get 2x. Sorry, we get 2x is equal to 9. So x is equal to 9 halves. And then the other number would then be negative 9 halves. Y would equal negative 9 halves. Because plugging it into the first equation, or plugging it into here, you get y is equal to 9 halves minus 9 over 1 times 2 times 2. 9 minus 18 is negative 9, so y is equal to negative 9 over 2. So those are the two numbers, positive 9 over 2 and negative 9 over 2. Okay, let's do another one here. We have Heather has been offered 2 options for her salary as a trainer at the gym. We have option A. Option A would pay her $25,000. So her salary, let's say we let that be Y. $25,000 plus 15 for every training session. So we have a value of $25,000, and then 15. Let's say the number of training sessions are X. So that's the salary for option A. Option B would say that would pay her $10,000 plus $40 for each training session. So Y would equal 10,000 plus 40x, or 40x plus 10,000. And in order to see how many training sessions would make them equal, you set these equal to each other, basically. Okay, so we would have 15x plus 25,000 equal 40x plus 10,000, and we're going to solve for x here. Okay, fine. So let's subtract 15x from both sides and subtract 10,000 from both sides of the equation. So what would that give us here? These will cancel. 25 minus 10 is 15,000 equals, these 10,000s cancel out. 40x minus 15x, that's just 25x. Okay, so then in order to solve for x, we divide both sides by 25. Okay, and then what is 15,000 divided by 25? 15,000 divided by 25. Let me double check that here. Okay. Sorry, I put 600. So X is 600. So that's how many training sessions would make the salary options equal. Okay, let's do another one. When Jenna spent 15 minutes on the elliptical trainer and she did circuit training for 20 minutes, her fitness app says that she burned 278 calories. When she spent 20 minutes on the trainer and 30 minutes circuit training, she burned 473 calories. How many calories does she burn for each minute on the elliptical trainer? So we have a number of how many calories for circuit training. So we need to set those as our variable. So let X equal number of calories burned on the elliptical. Using the elliptical trainer. And then Y, we'll let Y equal number of calories burned doing circuit training. Circuit training. Okay, so 10X plus 20Y will equal 278. Because that'll be the rate of calories burned per minute, okay? And then for 20 minutes on the elliptical trainer plus 30 minutes circuit training, she burned 473. So now we have a system of equations here. So what I can do is I can multiply this top one here by -2, and that gives me negative 20X minus 40Y is equal to negative 556. And I'm going to add that to the equation underneath it. Okay, and I'm going to combine these two. The x's are going to cancel out. So I'm going to get negative 10y is equal to negative 83. Divide by negative 10. So then the minutes, the number of calories burned per minute doing circuit training is going to be 8.3. So then to find y, to find x, we plug it into either one. So let's plug it into the first equation here. So 10x plus 20 times the y that we just found, 8.3, is equal to 278. Okay, 10x plus 166 equals 278. Subtract both sides by 166. We get 10x is equal to 112. Divide by 10, and then x is 11.2. So the calories per burned for each minute on the elliptical trainer is significantly higher than the calories burned per minute of circuit training. Okay, let's do this one here. Now we're going to go to geometry applications. So let's talk about complementary and supplementary angles. So they're big words. They don't mean that much. Okay, so they do, but let's say here we have two angles. Okay, two angles are considered complementary if we add them up and the measure of their angles is equal to 90 degrees. So measure of angle X plus measure of angle Y is equal to 90 degrees. That's when it's complementary. So this is complementary. Okay, these are geometric terms. If we have two angles where their measures add up to 180, so the measure of angle M plus the measure of angle N is equal to 180, we call that supplementary angles. Okay. All right, so let's do a problem using this terminology. The difference of two complementary angles is 26 degrees. So the difference, let's say x minus y, is equal to 26. Then because they're complementary, I know that x plus y is equal to 90. So see there, I have a system of linear equations. And notice that you have negative y and positive y. You can already add it together. These cancel out. You get 2x is equal to 116. Divide by 2, we get x is equal to 58. Okay, then the other angle would be y. So x plus y is 90. So 58 plus y is equal to 90. Just subtract 58 from 90. And the other angle is measures 32 degrees. Okay, so those are your two measurements. Alrighty. Supplementary, what if you have two supplementary angles? That means that x plus y is equal to 180. The measure of the larger angle, let's just let y be the larger angle. So y, it's arbitrary, is 12 degrees more, so that means plus 12 here, then 3 times the smaller, and the smaller angle is just x, okay? So now we want to find the measures of the angles. Since this is already solved for y, I'm going to plug it into this one using substitution. So I get x plus 3x plus 12 is equal to 180. Combining like terms, I get 4x plus 12 is equal to 180. Simplifying by using the subtraction property of algebra here, so of equality. So 4x is equal to 180 minus 12. What is that? 168 today. Divide by 4. We get that x is equal to 42. Okay, so if one of them is 42, the other one has to add up to one, gives us the rest. So 42 plus y is equal to 180, right? So we just need to subtract 42 from 180. And that's going to be 138 degrees. Okay. All right. Okay, so this one is uses the fact that the measures of a triangle is equal to 180 degrees also. So if I say A, B, and C are the angle measurements of a triangle, the sum of them is equal to 180, and that's for all triangles. So here we have the measure of one of the small angles of a right triangle is 10 more. So we have here a right triangle. So right triangle means that one of them is already 90 degrees. The measure of one of the small angles is 10 more. So let's say x, this is x and this is y. We have x is 10 more than 3 times the other small angle, so 3y. So we have x is equal to 3y plus 10. And we also know that because the angle, the interior angle theorem, that means that x plus y plus 90 is equal to 180. And you can solve that a little bit. So we get x plus y is equal to 90. So we can do substitution here, okay? So we get 3y plus 10 plus y is equal to 90. Like terms, 4y plus 10 is equal to 90. Subtract both sides by 10. 4y is equal to 80. And then divide by 4y. Oops. Why did it do that? Why did it do that? Y is equal to 20. It's acting weird. Okay, y is equal to 20. That's one of them. So then the other has to be, 70 because x plus 20 equals 90. So subtract by 20, then we get 70. So the other angle is 70 degrees. All right. Let's see here. How about a motion application? We have Joni left St. Louis on the interstate driving west towards Denver at a speed of 65 miles per hour. Half an hour later, Kelly left St. Louis on the same route, driving 78 miles per hour. How long will it take for Kelly to catch up to Joni? So we have two things going on here. We can do a little chart because this is a rate times time equal distance problem situation, right? So let's see here. We can create our little table, rate times time equals distance, RTD. And we have Joni and we have Kelly. Okay, so Joni is going 65 miles per hour. Kelly is going 78. The time spent, we can let that be X and Y. So the distance traveled, 65X, 78Y. The other thing is that Kelly left half an hour later. So the time that Kelly drives is the time as Joni, but minus half an hour. So x minus 1/2. Okay, so we know that. So then we can just, we can say, okay, well, we want to know how long will it take for Kelly to catch up to Joni. That means when are the distances going to be equal? So when is 65x equal to 78y? But we have here y is equal to x minus 1/2. So let's substitute that. We get 65x is equal to 78 times the quantity x minus 1/2. Distributing this, we get 78x minus, and then half of 78 is 39. So 65x. So subtract 78x from both sides. We get 65 minus 78, which is negative 13. X equals negative 39. Divide by negative 13, and we get that x is equal to positive 3. So if x is equal to 3, y is going to be 3 minus 1/2, so 2.5, or 5 halves, however you want to think about it. Okay, so those are the, so it will take Kelly 5 halves of an hour, or 2.5 hours to catch up to Joni. All right, and that's it here. That's your super fun homework for section 4.2. Good luck. You can do the odds or every other odd. Good luck. Happy studying, and I will see you in the next video.